Awesome. So thank you for joining us today. My name is Saud, and I am a member of the Brighter Spark Applied Research Team. And I'm presenting this introduction on behalf of Allison Van, who is the Executive Director of Spark, Center for Social Research Innovation. So welcome to today's Spark Talk, titled Moving from What Works to What Replicates with Bryan and Vivian Wong. I'd like to begin by giving honor and thanks to the Haudenosaunee and Anishinaabe nations as the traditional inhabitants of the land where McMaster stands. And to say that is to acknowledge a debt to those who were here before us and to recognize our responsibility as guests and stewards to respect and honor the intimate relationship Indigenous peoples have with this land. As for joining here virtually, I encourage you to reflect on the traditional lands and the people who those lands belong to where you live. So for some quick introductions, Dr. Vivian Wong is an associate professor of research, statistics, and evaluation at the University of Virginia. She's interested in experimental and quasi-experimental evaluation approaches, as well as developing new methods for the design and analysis of replication studies. Bryan Cook is a professor of special education at the University of Virginia. He is interested in open science, meta-research, and evidence-based practices for students with and at risk for disabilities. He co-directs the Special Education Research Accelerator, a platform for supporting crowdsourced research in special education. So I will now hand it off to our guests.
Thank you, Saad.
Right. I'll go ahead and share the slides. Is everybody able to see the slides? Yes. Great.
Do you want to do the first slide, Vivian?
Sure. Welcome, everybody. It is so nice to see you. Bryan and I have been collaborators now for a few years. I am a methodologist and a statistician by training, and Bryan is a special education researcher. And our interests collided together in thinking about open science issues. And as a result of that work, we have spent quite a bit of time sort of thinking about open science specifically, but also replication issues more generally. Today, we're going to lead a conversation about open science and replication and why or why not folks have been thinking about these issues. It's a small group today, so you should feel free just to interrupt as we are speaking. And we can also have this to be more of a conversation. If this is something that you're comfortable with, please feel free to do so. Bryan, why don't you go ahead and take it away?
Great. Thank you. And then just to reiterate what Vivian said, if there's anything you'd like us to expand on as we go or you have questions, given especially the small group, we're happy to do that. Give us the next slide, Vivian. A brief overview. I'll start off and talk a little bit about some efforts. I'd actually be interested to see how much this is happening in Canada too. But in the US, a real focus, at least in education research, around identifying what works based on research. And a lot of that is tied up in results across studies replicating around the effectiveness of different programs and practices. And coming out of psychology, but really in a lot of disciplines, we see replication or reproducibility crisis and concerns that when we do try to replicate findings of studies, oftentimes those findings don't replicate. And so then we'll get into some issues about why results might not be replicating when they don't. I'll talk about questionable research practices and introduce preregistration as one approach to try to combat those questionable research practices and a potential bias associated with them. And then we'll get into the meat of I'm just setting up. Vivian will then talk about some of the work she and her colleagues have done, thinking about replication and how to design replication studies and plan and conduct replication studies so that we can pinpoint, not think about when or not focus on studies replicating or failing to replicate, but understanding how they replicate and don't replicate. And I said that very poorly, but Vivian will do a better job with that. And I think our big take-home message is that as much as it spawned a replication or reproducibility crisis, we don't think that failure to replicate results is a problem. That's probably just baked into social science that we should almost expect some level of failure to replicate. There are so many variables at play. And in fact, we think that should be, it isn't a bug. It's part of what's that saying now? I'm blanking on. It's not a bug, it's a feature. This is part of what we do in social science, or what we should be doing in social science, is teasing out why things didn't why things failed to why studies fail to replicate when they don't. And so that's where we're going with things. All right. So a lot of the work that I've done over the past 20 years, and it's interesting to look back in hindsight, in the field of education, there has been a big press, especially at the federal level, to identify what works. And I think it's represented very well in the federal government is funded since 2002, the What Works Clearinghouse. And they have a very kind of prescriptive system for reviewing bodies of research to identify what works. And I think in many ways that is well placed. Certainly one of the areas that social science can make direct contributions to practice is identifying practices and programs with and without empirical support that are most likely to have positive impacts on, in our case, student outcomes. But I think this applies across different fields in slightly different ways. So underlying this movement that is often called around evidence-based practice or evidence-based reforms, I think at the heart of it lies the replication, and that we have many different sets of standards to identify evidence-based practices. But a big part, essentially, they're all variations on the theme that we want replicated findings of positive effects of an intervention or a program or a practice, that across multiple high quality experimental studies that we find positive effects. In essence, at its base, it's just counting up. We have to have at least a few, and the different sets of standards differ on how many, but we have to have at least a few studies with replicated positive effects, with very few to no studies that show negative effects. At its heart, it's a simple equation. The primary focus then is that we're after trying to find the effect for a practice. And I think there's an assumption that there's this true effect that we want to capture, even though there's noise and potential error in every study, that if we look at studies across different replication efforts, that we'll find the effect for a practice. Even though that these studies are conducted with oftentimes significant variations in participant samples, in how the treatment or the intervention is conducted, and the outcome measures that are evaluated or used in the evaluation. And so that's where we're going with things, that to look for the effect, despite the significant variations in the studies being reviewed, maybe misses the point a little bit. In 2015, led by a professor at University of Virginia, where Vivian and I are, Bryan, and this is in the field of psychology, and it really kicked off this movement, or the recent focus on replication research. And they replicated 100 studies in psychology. There's a huge team of authors on this study, and in different teams, they each took a study from the psychological literature and replicated it. I don't know if you're familiar with this study or not, but 100 studies, 97 of the original studies had positive, significant effects for the main treatment, and which is consistent with the literature in psychology and many other fields. The vast majority of published studies have positive findings. So they replicated 100 of those. Anybody want to take a guess in the independent replications? How many significant positive main effects did they find of 100 studies? Type it in the chat. Shout it out if you want. Take a guess.
It wasn't much. Was it like 20?
Oh, you're stealing my thunder. It was actually more than that, but you're in the ballpark. Yeah. It was 36. And I remember reading this study and just walking around with my mouth agape, thinking, what does this mean for the research I've spent most of my life doing? That the findings that we thought had some validity, we try to do the same study as best we can, and it doesn't replicate. And these are some of the fancy graphs that they had that just show the mean p-value as opposed to being well below zero 0.05 in the original studies, well above 0.05 in the replication studies, and the effect sizes in the replication studies were almost exactly half of the effect size in the original studies. Next slide, Vivian. Thank you. And so this is, people call it different things, but it set off a reproducibility crisis, and that to some degree or another, whether they think it is a significant crisis, and this was in 2002, just a slight crisis, but the vast majority of researchers feel that there is some level of reproducibility crisis. And what does it mean in our field? And I think in my little area of special education, what does it mean when we're telling practitioners and teachers to inform their practice based on our research, and yet maybe these findings won't replicate so much? One direction this is taken, and Samin Vaziri has written, I love how she frames these issues. She talks about, instead of a reproducibility crisis, thinking that, of this as and now I'm blanking on what she calls it. She calls it it's not reproducibility. It is a credibility revolution, she calls it. So what steps can we make to reduce bias and in our research to enable or to promote replicable, reproducible results? And so this is a figure that Dorothy Bishop used in a blog post, where she brings up some prominent, what are sometimes called questionable research practices, such as it's one of my favorite acronyms, hypothesizing after results are known. So you do essentially an exploratory study, you find something, then after the fact, say, yes, that makes a lot of sense. I don't think this is necessarily purposefully nefarious or misleading, but oftentimes I think the way that studies are conducted and written up, after the fact, we go back and hypothesize. And of course, hypotheses are designed to be a priori. And so it looks like we were predicting that result when actually we're explaining after the fact an exploratory result. Low power can lead to irreproducible findings. P-hacking is a big one. And I remember reading about this at first and just thinking about someone, I don't have significant results. What can I do to manipulate my data analyses to get to that kind of mythical P less than 0.05 level? Can I covary for certain things? How am I going to handle outliers? Is there a different model I can run? And lots of taking advantage of some of those degrees of freedom that we have. And then publication bias. Probably don't publish a lot of our studies. And so the ones that find their way into the published literature base may be biased towards positive findings, because that's what reviewers and editors and journals may be most likely to publish. All right. Pick up the pace here, Vivian. Sorry. Real quickly, that vision that I had of data analysts p-hacking and consciously trying to get down to 0.05, Gelman and Locke pointed out that a similar issue probably exists that is much more common, where it isn't a conscious effort to try to get findings down below 0.05, but that we have data-dependent analyses. So we look at our data, think about what analysis makes the most sense to run. And even if we're just conducting one set of analysis, there are choices along the way that we make. And there are all sorts of analyses that we may have run out that are represented by this point. Garden of Forking Paths, by the way, is a short story that I've never actually read, and I should someday, that would produce different results. Each of these different types of analyses, each of these different endpoints of analyzing a study. And we're only doing and reporting one and treating it as if it was the effect for the study, when it's actually probably one of very many. And our choices along the way in analyzing the data are probably influenced by our knowledge of that data. And we may, at even an unconscious level, be biasing our analyses towards significant positive findings. Pre-registration, and this is something, if you're interested in pre-registration, we can come back and talk about, but I'm going to just skip over it real quick, or not skip over it, but treat it very quickly. Pre-registration is the idea is that we're going to post publicly our plans for conducting a study and analyzing the data. So what are the critical decision points that we're going to make? We're going to state those in advance. We're going to try to really think through our study as best we can and put all those out there. And this serves, I think, at least two functions. One is it provides a blueprint for the researcher to follow. So we've predetermined our path that we're going to follow, and we're not making data dependent decisions that may privilege more positive findings. We're going to say, this is what makes the sense, what we think makes the most sense and how to analyze it. That's what we're going to do. It also allows research consumers the ability to see what you said you were going to do and what you actually did. And if those differ, then that might be an indication that there was, consciously or unconsciously, some level of perhaps p-hacking or harking or some of these other questionable research practices in play. One thing to point out, pre-registration should be thought of as a plan, not a prison. One of the big concerns about pre-registration, I don't want to post how I'm going to do my study and analyze my study. That kind of evolves as you do the study. It does and should, but we should have the thinking of advocates of pre-registration is we should have a plan out there. When things change and we have to change, that's okay. But then there should be a transparent, documented record of that change and the rationale for that change. And pre-registrations can be updated, and that should be reflected in the analysis plan. I'm sorry, in the final paper. And then finally, pre-registration templates, I just wanted to throw out here. There are lots of them out there. And Center for Open Science runs the OSF, the Open Science Framework, and they have a number of different pre-registration plans, including one that's open-ended, pre-register whatever you want, but they also have specific ones for secondary data analysis and qualitative pre-registration. So it isn't just the experimental research that you can pre-register. And Grant, I saw that you had a comment, so I'll read that as Vivian takes over, and we'll respond when we have time.
Oh, you don't need to read it. It's just an interjection.
Yeah,
We can
we'll
see.
chat
If we
about
have
it
time
after
at the end,
we're
we
done.
can chat about it. How about that?
Yes.
Yeah, and definitely feel free to also interject as a conversation. So, Brian, as Brian mentioned, we have been involved in a number of different communities and disciplines and talking about open science and replication and pre-registration. And what's been interesting to me has been the different disciplinary perspectives in thinking about replication. And so in psychology, for example, I think the focus on replication was around conducting a lot of what they describe as direct replication studies. So in other words, trying to replicate exactly the same procedures and methods and protocols as similarly as possible, partly because I think maybe psychology might come from more of a lab tradition that makes this kind of approach more amendable, and then focusing potentially on questionable research practices. And in our home field in education, the conversation around replication has come from a different perspective, which is mostly focused on the idea first of whether or not the extent to which we should be conducting replication studies, the extent to which we do actually conduct replication studies, and how do we interpret replication studies that are conducted across different school settings and contexts with different participants or of student characteristics of different demographic characteristics. And to begin by setting the scene for this, as Brian alluded to earlier in the talk, about 20 years ago in the United States, education really introduced a major reform both in the policy side and on the research side, which was this effort to make evidence-based decisions around education practices and policies. So there was a push to institutionalize rigorous causal evaluation designs. And in this article that I've highlighted here, the director of one of the main sort of funding agencies is reflecting on the success of that initiative in terms of of how much we've actually learned over the last 20 years from this effort to institutionalize experimental and quasi-experimental design. And here he says that the problem with the model was that RCTs, as they were originally introduced, were about average effects across populations. But to use the specific example, we've now moved into individualized medicine about what works for you under what conditions. So the mantra of IES now is what works for whom under what conditions. And what that implies is that there's some interaction basically that happens between the delivery of an intervention and the context and the settings of which it's delivered, and that these contexts and settings and population characteristics have important roles in terms of moderating sort of the effects of the interventions themselves. And so what Mark articulates as the new direction for IES is to not just do replication where we conduct one study in New York City and another study in in Philadelphia, or with a different sort of population of kids, but the idea is to approach replication through a systematic approach to replication, where you systematically vary different conditions with the goal of trying to understand the robustness of effects across these systematic sources of variation, but to also begin to identify why results may not replicate. And what I think what one of the challenges with taking this approach is that until fairly recently, is that we as a field really do not have a unified definition of what replication means. And we don't also have a sort of a unified definition about what the criteria for what makes a good replication study. And for funding agencies, this poses a problem because if there are competitions, if you're holding competitions to fund replication studies, then reviewers need to be able to evaluate what do we think of as being a good high quality replication study here. Okay. In the next part of the talk, what I'm going to do is I'm going to talk a little bit about what our proposal for what a good replication study is and the logic of that kind of design. To set this up, I'm going to begin by citing this quotation from Schmidt, which I think many people refer to and use as what the definition of replication is, right? Replication is a methodological tool based on repetition of procedure that is involved in establishing a fact, truth, or piece of knowledge. Okay. And here I've highlighted the the repetition of procedures, because most definitions of thinking about replication emphasize the repeating of an experimental procedure. And in fact, this is what Bryan and his colleagues defined as exact or close replication in their own sort of efforts to conduct replication studies. For example, close replications refer to those replications that are based on methods and procedures as close as possible to the original study. Okay. Now, if you've actually conducted a replication study before, you can start to see there's some challenges with thinking about this as our standard for a high quality replication. So here, the standard for a quality replication is going to be judged by how closely replication is able to repeat methods and procedures from the original study. Okay. But the challenge with this in practice is that, first of all, the original study may fail to report all of the relevant and necessary methods for being able to replicate the procedures, making direct replication difficult, if not impossible, right? And then the second issue that often comes up is that our state of the art changes and grows over time. And also things deviate from the protocol, even in sort of original studies. And question becomes if there were deviations from the protocol, or if our sort of knowledge of how to implement methods and procedures have improved over time. In a direct replication study, is the intention here to replicate the original methods and procedures that may have been flawed, or to reflect the state of the art in practice? And what this sort of brings up is that it reflects this inherent tension in understanding why we want to do replication, right? The idea for replication at its core is to try to understand some durable fact piece or knowledge, right? That by replicating original methods, that seems to be getting at some other goal of replication. Okay. Let's go back to this definition that Schmidt has provided and think about how we can use this definition for our understanding of replication, because I think this is a pretty good definition, right? But instead of focusing on the repetition of methods and procedures, where I want to highlight your attention is to the establishing of a fact, truth, or piece of knowledge here, right? That the core goal of replication is to be able to uncover or to identify durable facts or knowledge that is robust across sort of sources of variation here. And in the last 50 years or so in the program evaluation literature, we have a way actually to formalize what we mean when we're talking about fact, truth, or piece of knowledge. Basically, here in the program evaluation literature, Ruben and colleagues have developed a notation using what's called potential outcomes notation, right? And basically, here we say that using potential outcomes notation, we say that the goal is to replicate the causal effect of a well-defined treatment effect that we're going to call a causal estimand. And a causal estimand here is just basically defined as a causal effect of a well-defined treatment control contrast. This is for impact evaluation studies for a clearly defined target population and settings. Okay. So what this implies, the subtle sort of distinction here is that what this implies is that repeating methods and procedures will often be helpful in achieving our goal, but it's not necessarily always required. And sometimes it's actually not desirable for it to repeat exactly the same methods and procedures. And so what I'm going to do now is I'm going to introduce what my colleague Peter Steiner and I from the University of Maryland call the causal replication framework. And this framework basically describes, at a very minimum, what are the basic assumptions or the conditions that are required for two or more studies in order to reproduce the same causal estimand here. Okay. And so basically, this slide describes what the 5 assumptions are. In our technical paper, there's a derivation for this, but here I've only just highlighted conceptually what they mean. And basically, what you can do is you can group these assumptions into 2 sets of assumptions, where we'll start with the bottom 2 rows. So the bottom 2 rows are what we call basically the assumptions that are required for any single study. So any individual study that you conduct to yield an unbiased and correctly reported treatment effect or intervention effect here. What this includes is that your causal estimand or your effect is identified by the research design and that it's correctly estimated. Okay. And that your estimates are basically correctly reported. So this 3 here basically speaks to questionable research practices, right? What combined with these bottom rows here provide these assumptions that guarantee that each individual study in the overall replication effort produces an unbiased result. And then the top 2 rows basically describe what we call replication assumptions. So that basically across the different studies that are included in your replication effort, that these assumptions are basically met. So what do they include? Treatment and outcome stability basically mean that the treatment and the control conditions are the same across the different studies that you're comparing effects for. Okay. Outcome stability means that you're measuring outcomes in the same way and that there's measurement non-invariance across your different studies. Okay. And then the equivalence of the causal estimand basically means that the settings, the context, and the populations are the same across studies in a way that would potentially moderate effects. Okay. And so what you can see by this is that in order for study effects to actually replicate across sort of multiple studies, especially studies that are being conducted in field settings, the assumptions that are required are actually quite stringent. There are a number of different reasons, including questionable research practices, that might occur that would yield to different studies yielding different results here. Okay. And what we think is helpful about this framework is that it starts to provide a formal definition of how we think of different replication designs, right? For example, the type of replication studies that people usually describe as a direct replication are basically studies, multiple studies that attempt to replicate the same effect where the causal demand is exactly the same. Okay. And there are examples basically of direct replication efforts in which you might use, for example, you might systematically vary basically the research design that's being used in order to be able to identify an effect. For example, an experimental design versus a quasi-experimental design that refer to the same target population. And that would be an example of a direct replication study. Reproducibility efforts that use sort of the same data and the same sample, but might have different reporters rerun syntax or code would be example of a study that tests whether this assumption of correct reporting. Okay. And then there might also be conceptual replication designs as well. And then conceptual replication designs here, what the researcher is doing is they're purposely relaxing one of these assumptions while trying to meet all of the other assumptions here, right? For example, we would call multi-arm treatment designs examples of a conceptual replication design, right? Or multi-site designs where you might randomize individuals within sites, but there's variation across settings and contexts and participant characteristics as examples of multi-site designs. Okay. So a second implication, I think, from this framework is that, yes, the assumptions for conducting a strict replication design or strict replication are pretty stringent. And there's lots of reasons why replication failure may occur, but that there are also pathways in which we can conduct replication designs in which we systematically vary these different assumptions, and that these are already research designs that we use in settings commonly, but we don't recognize them fully as replication designs. What's the implication, I think, of thinking about replication and from a research design perspective, right? First is that basically replication failure occurs when one or more of these 5 assumptions are violated. And that if you're thinking about the assumptions from a research design perspective, researchers can quickly test one or more of these assumptions systematically by introducing variation for testing a specific assumption around, for example, variation in settings or variation in participant characteristics, while trying to address all of the other assumptions. And the reason why it's important to be able to address all of these other assumptions is because if you find that results do not replicate, the important part here is that you want to understand why the results don't replicate, right? Sometimes they don't replicate because there's bias in the studies, and that's important to understand from a methods perspective. But from a social science perspective, when you're conducting field research, it's also important to understand if results don't replicate because there's something about your participant characteristics that interact with the intervention that might produce replication failure here as well. And so what we suggest is that folks begin by thinking about this from a research design perspective by trying to systematically vary while holding constant other sort of assumptions here. And because we work in a field and because we work in field settings, oftentimes it's not possible for researchers to be able to meet all of the assumptions that are required. And so what we suggest then is for folks to think prospectively at the beginning of their study by thinking about first what assumptions they're going to systematically try to vary. Okay. And then basically plan sort of diagnostic measures to think about, to assess the extent to which assumptions are going to be met or not met in field settings, right? For example, in many randomized controlled trial studies now, it's become standard practice to report basically balance tables demonstrating that groups are equivalent in treatment and control groups as a way to convey to readers basically how much did randomizations or create equivalent or balanced groups here. In the same way, being aware of what the assumptions are required allows for researchers then to be able to plan prospectively what diagnostic measures they can put in place in order to be able to report the extent to which these assumptions are met or violated in field studies. And then for those of you guys who are meta-analysis, eventually what we want to do with results from replication efforts is to meta-analyze these results, right? And having consistent ways in which people report the extent to which their assumptions are met or not met in field settings also would support the analysis of these results in a meta-analytic framework as well. Okay, so I'm aware of the time we have. So basically, I'm going to skip over these slides, but I have an example here where we have a grant funded from the Institute of Education Sciences, where we implement this prospective replication design approach to evaluate a reading intervention called ReadWell. And basically, our process for designing this evaluation was first to think about what are the sources of effect variation that are theoretically informed that we really want to understand, that we think that basically intervention effect would be highly moderated by interactions with these characteristics. Here, this includes in terms of how the treatments were being delivered. Were they delivered by intervention specialists, or were they delivered by teachers that we trained in field settings? Another sort of hypothesized moderator was around kid characteristics who were receiving the intervention. So here, this was whether or not the students were English language speakers or non-English language learner speakers, as well as by settings. We had 3 sort of geographic locations with school sites in California, Texas, and Virginia. And so basically in our proposal, what we did was, I know you can't read this, there's too much information here, but basically what we did was we identified in the proposal what were the systematic sources of variation that we wish to test. And then we described what the research design that we were going to use to test sort of each of these hypotheses of moderators, and then describe how we were going to assess whether the other assumptions that we weren't testing were met here. And then finally, I guess what I want to highlight here is that my colleagues, Kylie England and Peter Steiner, we have the paper where we talk about replication through the design and planning phase to implementation and reporting phase. And what we really emphasize is first using subject matter theory in order to identify sources that affect heterogeneity that you wish to test in your replication efforts, and then to think about what the research design is that you're going to use to test these sources of effect heterogeneity, and plan your diagnostic measures, and then to basically pre-register this information that Bryan talked about at the beginning to be able to identify what your plan is for analyzing and interpreting results, because it becomes quite a bit more complicated once, instead of having a single study, interpreting results from multiple studies. Okay, I think I'm going to pause for now. That was a lot of information, but I would be delighted to open it up to hear questions or responses from folks.
Thanks for coming to talk to us. That was I like that exposition. Good formalizing of that kind of thinking.
So can I ask a little bit about what your backgrounds are and how you guys think about replication or an open science issues? What are the things that are in your mind?
I'm a quantitative social scientist. I'm an economist by training. I work at a research institute that has a bunch of secure data labs. So 0 open data, but fair data in the sense that it is accessible to anyone else who might want to apply for it. And so we're thinking through what we want to do about replication because the biggest thing that hurts us is not the fact that there's an application and security review process. That doesn't matter. It's the constraint on the secure resource that matters most. We couldn't possibly replicate every study, or sorry, not replicate, conduct the reproducibility check for every study that came through our doors, just because it would essentially double the workload on the system. And so this is a nice way of, it made me think a little bit more clearly about some of the issues that we come across. But most of what we're thinking about is what I'll call computational reproducibility. If I take the code, do I get the same numbers at the end? That's where we're at right now. And we had a really fascinating talk last week with a guy who set 1,000 researchers to the same task and came out with this secondary data analysis type of task and came out with 1,000 different sets of coefficients. And basically you can think of a distribution of effects and effect sizes, which to Bryan's point leads me to this thinking that your pre-registration actually probably should be a prison. And that's very narrow to my world of secondary data analysis. I think obviously when you start looking at the cost benefit analysis, qualitative setting where you get instant kind of feedback and maybe something you thought of really isn't going to work immediately, that I can see there being a rationale for being able to amend things on the fly in a pre-registration. But for secondary analysis, just having seen that last week, that sort of density of estimated effects made me a little more hard line in terms of pre-registration, what that should maybe look like.
Yeah, I put in the chat. Did you see this paper by Chang and Lee, or maybe that was one of the speakers who came? But basically, I think he tried and they pulled basic papers from econ journals. And basically that's because some of the econ journals have this requirement for sharing your data and sharing your syntax file. And basically they pulled those papers and tried to replicate results from that. And here in that case, right, that's a reproducibility effort. And you would think that all of those other assumptions that you're worried about, right, in terms of identification, estimation, treatment outcome stability, causal estimate, those should all be met. That you're clearly testing reporting then, and they found that they had pretty low rates of replicability just even from that exercise on its own. And
that's consistent with a slightly later effort to do the same thing with the American Economic Association journal. So I mean, that tracks that kind of half thing. It's better than the psychology people.
Yeah. I think where we are trying to get to in our lab is that in the pre-registration phase, basically to pre-register the code that goes. For causal studies, it's quite straightforward, right? Because it's a confirmatory analysis of a well-defined causal estimate. And if you can pre-register your plan, you should in theory be able to also pre-register the code that goes directly with it, and to write the code around pretest covariates, but then just at the lab, and then run the code basically when the data is collected. So that is where we're trying to get to, but it requires a lot of things to be set up at the front as well.
Yeah, we would have a problem doing that. I love that idea. I'm working on making the very first, I haven't even got in to start doing it, but the very first structural file for one of our data sets where it's like same variable names, same, like for each individual variable, same rate of missingness, averages, and maybe I can get variances in some cases, but I think there'll be some places where that poses a problem. But just that would even let somebody do that, right? Because you come into the lab and you sit down and you're like, oh man, this variable's missing 30% of the time. And that's where I am sympathetic with people who are anti pre-registration, is that, in cases where your data wasn't what you thought they were. But I think as a data custodian or a custodial organization, I think we have a responsibility to reduce that gap or minimize that or eliminate it if we can, without having issues around confidentiality. Nobody should be changing the registration based on the correlation between two data points, but I can see somebody wanting to change something if one of the variables that they were intending to use just doesn't capture information about a significant portion of the samples.
Yeah.
And then in field-based research, I think of all the different open science practices, I think pre-registration is open data too, but pre-registration and open data, there's a fair amount of resistance to. I think pre-registration, there's maybe more resistance to, at least in my experience, just with conceptually, there are a lot of people who are resistant to it. And I think for me, it's field-based researchers, people who are doing intervention work primarily in schools. And I think a lot of it, you touched in some of the issues around secondary data sets that are unforeseen. But I think for the field-based researchers in schools, things change a lot because they're in schools and the principal says, no, after all, you can't do an 8-week intervention. We don't have time.
Yeah.
Do this and that outcome measure you're going to do. Yeah, the teachers don't want to do that after all. And this kid moves or whatever it is, things just change. And that ability to still, I think the spirit of pre-registration, but that so you can adjust but then adjust the pre-registration and have that reflected in the updated pre-registration to reflect the reality of doing school-based research. But that's different.
Yeah.
We're talking
But I do want to poke you a little bit on that, because I think as a researcher, you should be able to anticipate that maybe some of your subjects are going to move. And then that's part of your pre-registration. Obviously, if you don't have the budget to follow those people, then you have to drop. That's fair. I don't think anyone would argue with that. The question of getting into an environment, I don't, and I know this is so alien to my world, but to what extent if research funders really meant what they said, and that's always one of my things. Do you mean what you say when you talk about this stuff? If they meant what they said, would they increase funding a little bit or apportion funding so that you could do a small pilot study of intervening with students that weren't going to be in your sample, just to, how's it going to go, right? Like, what things that I can't foresee now about working in this school are going to happen. And then it's like machine learning, right? You don't test on the same data that you train your model. So you train your intervention on a set of students who aren't going to be in your model, and then go forth and actually collect your data. So I realize it's more work, but all these things are more work, right?
But also I think, Bryan, so we have a IES grant where basically the idea is that the challenge is that when you have to apply for grants, like your research design already has to be set in place, but we have this other work that Bryan leads around organizing teams of researchers to collaborate together in order to be able to carry out basically a series of studies in a coordinated way. And that requires both sort of the coordination of the teams in advance, as well as piloting the studies and the data collection in advance in order to be able to do that. And our argument has been trying to tell funders, look, the planning of the studies themselves is a fundable effort that should be, I think, that funders look at as well for certain questions that feel important.
Yeah. And I recognize we're over time, so I don't want to keep you longer than you need to, but I think in Canada, we do have a bit of a luxury where, some of the big granting agencies will do large multi-year funding projects where you actually do have the luxury of, okay, if I get funded, I'm actually able to spend the first year hard at work on planning for years 2 through 5. And it's not infinite time. You'd always want more time, but at least it's okay. I don't actually have to have every single duck in a row because it's expensive to line up ducks. So it's a nice feature for all of my occasional complaints about the tri-councils, it is actually a nice thing that they do on some of their opportunities. So
I know we have to sign off, but Grant, let me just mention Jeff Smith at University of Michigan economist is also working on a metric to report, in addition to standard errors, but researcher degree of freedom.
We do that kind of now, and there's a lot of people working in that. But lovely presentation. I don't know if I'm still in the audience, but thank you for coming. It's always wonderful to hear your stuff on this material.
Thank you.
Yes, and before we jump off, thank you again, Bryan and Vivian, for the amazing talk and for staying extra time. Bryan, you mentioned that like reading the psychology replication study and your mouth was agape. This talk and previous week's talk have been those moments for me. And I'm just finishing up undergrad and different field. Yeah, thank you so much. And Grant,
That's great.
again, for those questions.
Thank
Well,
you. very
thank you.
much.
Oh, bye. Great. Thank you for
Okay.
inviting us.
Bye, everybody.
Thank you.